First, the angle. Solar panel output depends on panel angle and direction. This is because the larger panel surface exposed to solar irradiance can generate more energy. Second, latitude changes. Energy production at different latitude changes from 0 degree to 23.5 degree. Latitude changes occur due to the tilt of the Earth axis, which causes seasonal weather variations throughout the year. Third, local solar studies. Limited research focused on Malaysia's climate and latitude changes. Fourth, fixed angle PV system. Finding the best fixed angle can improve efficiency at lower cost. First, the changes in latitude effect PV output. Different latitude receive different amount of sunlight. This changes the voltage, current, and power produced by the solar panel. Second, difficulty in finding the best tilt angle. It is difficult to determine the most efficient tilt angle between 15 and 20 degrees because small angle change can affect solar power generation. Limited previous research. There are not many studies that focus on how latitude changes influence solar energy harvesting performance, especially for small tilt angle ranges. First objective is to design and develop a 180-degree multi-directional photovoltaic energy harvesting system to obtain the maximum power point at PV orientation between 15 and 20 degrees. Second, to determine the optimal orientation for maximum energy harvesting throughout the 3 months.
Hello, this is my video demo, which is I will explain about the design and the methodology of the system. For the design, we have 5 panels which is facing different direction, and in the middle we have the compartment which is to put our component. Flat panel have more water accumulation on the panel surface, while the direction panel have less water accumulation on the panel, so this water will affect our energy. Now we have our load resistor that we connect with current sensor and voltage sensor to get the output. Now we have SD card module, RTC, and our microcontroller, which is Durian Uno for our data logger. So this is the full of our system, which is data logger system to measure the output from the panel. The LCD will present the value to monitor the data. So the project use off-grid photovoltaic system, which is supply our circuit for data logging, and use MPPT. Also connect with the battery as our backup supply.
The result, a flat panel can cause more water accumulation on the panel surface, but it is efficient during peak sun hours. If the panel clean, the panel direction can reduce water accumulation on the panel. However, the energy output may vary due to the changes in latitude. As we can see, this is the data in May for 1 day. So basically, in May, the latitude near to 23.5 north. That's why the power that produced from panel that facing north produce more energy compared to other, and the quantity of water on the panel and the energy output inversely proportional each other. This is the result for current and voltage. The north facing panel produce the optimal voltage and current of 16.30 volt and 1.043 ampere. Novelty, this study introduced a technique to achieve maximum power output from solar PV positioned at a tilt angle between 15 and 20 degrees using 5 multi-directional orientation for energy harvesting within 0 to 23.5 degree latitude throughout the year. And for the benefit, it supports experimental learning in renewable energy, especially for engineering students working on photovoltaic system. This project helps students understand how photovoltaic system work in real life situation, especially for engineering students can learn how panel positioning affects voltage, current, and power output. Second benefit is increased public understanding of how factors like latitude, tilt, and irradiance affect solar energy generation. The project increased understanding of factors that affect solar energy generation. It also explains why proper panel orientation is important for maximizing energy output. Initial, first, research and educational use. Renewable energy act like learning kit for education and training, useful for universities, college, and training center for research. Solar PV installation. Improve fixed angle solar panel installation efficiency, help achieve higher energy output at lower cost. Malaysia Green Energy Development supports renewable energy development in Malaysia, contribute to sustainable and energy efficient solution.